All right, guys, let's go ahead and get moving forward here. So, all right. So I want you guys to do a little bit of investigation, kind of thinking about this in your own minds. Why are the minerals that we talked about, some of them are really important, some of them are not. Well, why are minerals important? What's the point in knowing your minerals? Alex?
Is it like a health issue too? Yeah.
Like the hippies, yeah, I can. All right, so yeah, we can use them. All right, yeah, because they have different uses, right? One of them there are definitely health related. Not really. So I know we kind of talked about this earlier, right? It was some individuals thinking that the quartz crystals actually will cure your arthritis if you have it. I'm not one of those individuals. I do not subscribe to that belief. What are some other reasons why minerals might be important? Where do we use them? Think about their uses. Okay, so foods.
Yeah.
Yeah, that's explosive, so we'll go ahead and put that down. And there's actually quite a bit in manufacturing. These are really, really big things to really think about when we talk about manufacturing in terms of the minerals that are used. And that's kind of the big thing I want you guys to understand, is a lot of our minerals that we use, we put those under this category called natural resources. One of the reasons why the United States was able to go into World War II and actually come out dominant was because of the abundant natural resources we have within our own borders. And we were actually able to make manufacturing become the norm on how to make your nation one of the greatest in the world, which is no surprise that as soon as we left manufacturing as the main source of American pride, China picked up right away and it was right away, and now it's become one of the leading countries in terms of business. I think we made a bad choice about 20 years ago when we decided to go to a service-based industry, but not much we can really do about that. So these natural resources, we look at mineral. A lot of the minerals that I have that I collect are mostly that. They're just collectibles. Just like some of you guys might have things that you collect. So how many of you guys collect action figures? Yeah, I know. I agree, right? Okay, so what is that? If you ever go to like an antiques show or shop, and you actually look at the toys that they have offered, and you're like, yeah, I don't play when I was a kid, and you realize that the price of that toy is now like $150, and it's a tiny Matchbox car that costs $1. And you're like, okay, that doesn't make any sense. Well, it basically comes on this idea of what's collectible and what's not collectible. And the same thing with rocks and minerals. So for a lot of you guys, when you go to the show this weekend, for extra credit, if you go, you'll see a lot of these different rocks. You look at the prices, you're like, well, you got a kid, it costs that much. And it's because mostly, one of the two ways that minerals are priced is based on the beauty of the individual sample itself, as well as the rarity of the sample. And so that can kind of drive prices up or bring them down. So it's left that go into that. So I want to talk about more on the natural resources, and we talk about how we use these, right? We basically get these out of ores. And so basically, we look at our natural resources, we look at the minerals that are involved. We get these from ores. Now, ore is really nothing more than a substance that has or like a rock, basically, that has a very valuable substance in it. This big chunk right here is called iron ore. It's mostly rock. Actually, pay attention. Okay, so it's mostly rock, but it has iron chemically compounded or chemically bonded inside the rock itself. So it's not like you can just basically crush this up and you're going to find a bunch of iron left over. So what we have to do is we have to first get this out of the solid rock. This comes right out of the solid cliff face. So that you have to use explosives. And then they bust up the cliff face. And then they put these in a big truck. And then they drive the truck over this plant. The plant drops this into the chute, into this little thing called a hopper. And it basically gets crushed. And then it goes after that, and it gets crushed further. It gets crushed further and further and further. Eventually it gets down to like a really soft powdered form. From there, it's put into a furnace where it's completely melted down to molten state. At that point, the iron being so dense, then basically filters itself on that molten state and actually solidifies at the bottom. So that's kind of what the smelting process is. Yes?
This is a weird question, but can all rocks be, like, all rocks turn to dust?
Yes.
Really?
Yes. Is it a national park? Yes. So basically the rule of thumb is take nothing but pictures, leave nothing but footprints. That's the rule of thumb for national parks. By the way, in some of your research, you guys come across how many different minerals there are on Earth itself?
4,000. A lot.
How many?
4,000.
Close to that. I'd say 3,000 to 4,000. Anywhere from 3,000 to 4,000 minerals. We don't need to memorize them all.
Thanks.
You should make caps to be memorizing all teachers.
Okay, now we kind of already stated this, but this is why it's important for us to rewrite this down. So if you have this written down, I want you to write it again. This helps you kind of put it in your mind. All right, so looking at this, in order to be a mineral, you first have to be naturally occurring. So it can't be man-made. I say that, but then I'm going to kind of make myself a liar later. Has to be inorganic. What does that mean? What? Because what does inorganic mean? Yes? Not man-made, right? So inorganic means not man-made. And basically what's the most important piece to remember out of that is that it basically cannot be made from living things. So think about coal. What is coal made from? How do you get coal?
It's charcoal.
Okay, let's think of fossils. Is that a mineral? So is alright, so are fossils minerals? Okay, that's a really simple question. First of all, are fossils naturally occurring?
Yes.
Are they inorganic?
Yeah.
Do they come from living things or non-living things? So therefore they're organic. Okay? When we think about coal, coal is actually created by having layers and layers of biomass compressed, usually in bogs or swamps. And over millions of years, all that biomass basically degrades down into pure carbon. And that's how we get coal. So that's, again, coal is not a mineral because it's not inorganic. One of the things we also said is it does have to be solids. We can't have liquid crystals.
Is that possible? Oh, great. Like, what about the one?
Those,
Yeah.
in their dissolved state, they're not minerals. They're definitely chemical compounds, but they're not minerals. And they do need to have a specific chemical composition which is unique to every type of mineral. Every mineral has a unique chemical structure It makes it different from any other mineral. And then finally, we need to have definite crystalline structure. So, 1 minute question. You know, once you take a minute, once you consider the following questions, and I want you to be ready to respond